Hi, welcome to class. In today's video, we'll be looking at trigonometric ratios and functions. This is a very interesting topic. Okay, so now we are going to generate the 6 trigonometric ratios, and then we also look at how to generate the functions, the trigonometric functions of special triangles like 45, 60 degrees, 30 degrees, 90 degrees triangle. Okay, so let's quickly look at the trigonometric ratio. We'll be using a particular formula that you are conversant with, that is SOHCAHTOA. I will explain to you what this acronym means. Okay, so let's have a right angle triangle. This is a right angle triangle. This is angle 90 degrees. And let's choose, this is a theta. This is an angle, any angle. It can be any angle at all. So let me choose an angle theta here. If I have this as angle theta, and maybe let me have this as angle alpha, any number, okay? But this is 90, right? So we start. We have sine theta. I have cosine theta. I have tan theta. Then I have their reciprocal. The reciprocal of sine is called cosecant. You can use this to represent it, cosecant. Alright, cosecant simply means the reciprocal, that is 1 over the sine. Whatever you have as your sine, you turn it, that will give you the cosecant. Alright, so for the cos theta, the reciprocal of it is called secant. So secant here, whatever we have as our cos, you turn it, that will give you the secant. Then we have the cotangent, cot. This is the reciprocal of tan. Okay, fine. Now let me just use only one angle here. Let me remove this. Then let me put the sides of this triangle. Let me call it any name. Let me call this A, B, and C. Okay. So now SOHCAHTOA is telling us that S here stands for sine. This is sine. C here stands for cosine, that is cos. YT here stands for tan, tangent. Okay, then these ones are the ratio. Then this sine theta is equal to O. This O means opposite. Opposite over H stands for hypotenuse. Hypotenuse. Okay, so opposite simply means the side facing the angle. So this side facing this angle is called the opposite of this angle. The longest side of a right angle triangle is called a hypotenuse. So this is called a hypotenuse. Then the side where the angle is sitting down on is called the adjacent. Adjacent. Okay? Alright, so now we have sine theta. Sine theta is equal to opposite over hypotenuse. So opposite, our opposite is A over hypotenuse. Our hypotenuse is what? C. Are you getting it? Good. Let's go to cos. Cos theta, Ka, adjacent over hypotenuse. So A here stands for adjacent. What's our adjacent? I said adjacent is where the angle is sitting down on. So that is B. B, let me write it, adjacent over hypotenuse. So our adjacent is B over hypotenuse is C. Is that clear? Good, let's go to tangent. Tan theta is toa is opposite over adjacent. Opposite, see opposite over adjacent. And our opposite is A. And our adjacent is B. Once you're able to derive these 3 major trigonometric ratios, to find their reciprocals will not be a problem. So I said the reciprocal of sine is called cosec. So reciprocal means you turn it. The denominator will now become the numerator will become the denominator. So if we do that here, we're going to have hypotenuse over opposite, which is C over A. Cosec is the reciprocal of cos. So this will go up, this will come down. So I have hypotenuse over adjacent, which is equal to C over B. So we go to cot theta, reciprocal of this. So I'm going to have adjacent over opposite. So this is equal to B over A. So these are the 6 trigonometric ratios that we have. Now we're going to look at how to generate trigonometric functions of special triangles. Okay, so let me quickly write this here. So my sine theta is equal to opposite over hypotenuse, cos theta adjacent over hypotenuse, tan theta is equal to opposite over adjacent, then cosec theta hypotenuse over oppo, sec theta hypotenuse over adjacent, and cot theta is adjacent over opposite. All right. So let's look at how to generate the trigonometric functions. We first of all start with, of course, all the things we are working with is right angle triangle. So let's start with a right angle triangle that has, this is 90 degrees, that has angle 45 degrees. So if this is 45 degrees, remember the sum of angles in the triangle is 180. So if here is 90, automatically this plus this should also give you 90, right? So if here is 45, here will definitely be 45 degrees. Is that understood? Good. Now because they have the same angles here, it's by implication, it means that their sides are equal. This side and this side, that they are equal. So let's assume a side 1. If here is 1, this place too will also be 1. Alright, so how do we now get this hypotenuse? Remember the Pythagoras theorem of right angle. Pythagoras theorem states that if I have A here, B and C, the longest side of the right angle triangle is called hypotenuse. So according to Pythagoras theorem, it said that hypotenuse square is equal to opposite square plus adjacent square. Is that clear? So hypotenuse square is equal to opposite square plus adjacent square. So in other words, to find my hypotenuse, I'll simply do, remember this is square, so I'm going to take the square root of opposite squared plus adjacent square. So let's apply it here because this is the hypotenuse, we want to find it. So this side will be 1 squared plus 1 squared, then take the square root. Are you getting it? Good. So this is 1 squared is 1 plus 1 squared is 1. 1 plus 1 will give me 2. This will be root 2. So the hypotenuse here is root 2. Good. So with this, let's generate this sine 45. Sine 45 using SOHCAHTOA. So sine 45 is opposite over hypotenuse. Opposite is 1, hypotenuse is sine 2. Cos 45 degrees is adjacent over hypotenuse, which is the same thing as 1 over. Then tan 45 is opposite over adjacent, which is 1 over 1 and is equal to 1. So these are the special angles or the special functions. So sine 45 is equal to 1 over sine 2. But there's what we call rationalization of SOHD. That's if I don't want SOHD, that's root 2 to be under, I can rationalize it. And how do you rationalize? You simply do 1 over root 2 times it by the same root 2 over root 2. You know why? Because root 2 over root 2 is the same thing as 1, right? So anything times 1 is still itself. So if you do times root 2 over root 2, you've not committed any crime. It's the same thing, okay? But the reason why I want to do is so that this will clear this. It's called rationalization of sort. So 1 times root 2 will give me root 2 all over. Root 2 times root 2 will give you root 4. And root 4 is equal to 2. You see, there is no longer root down. So this thing is the same thing as saying root 2 over 2. So I can call this one the same thing, root 2 over 2. This one is equal to 1. So let me write it by the side, so I'll go to the next triangle. So I have that my sine, okay, we've already gotten this, the SOHCAHTOA, so let me clean this. So that I have sine 45 is equal to 1 over root 2, which is the same thing as root 2 over 2. Cos 45 is equal to the same thing, 1 over root 2, which is the same thing as root 2 over 2. Then tan 45 degrees is equal to 1 over 1, which is the same thing as 1. So these are the major ones. You can get the cosec here. I told you cosec simply means the reciprocal of sine. So you can, cosec of 45 will be 2 over 42, root 2. Sec 45 will be opposite, you understand? Alright, and cot 45 will be the same thing as 1 because 1 over 1 is the same thing as 1. Alright, so that's that for 45 degrees. That is 45, 45, 90 triangle. Let's go to another interesting one. That is 30, 60, 30, 60, 90 degrees triangle. Before I get this, I want to show you how to generate it because it's always good to know how to generate it. Not just memorizing tan 30 is this, cos 30 is this. Also know how to generate it so that if you can't remember it, you can quickly draw the diagram and generate it by yourself. So we're going to generate this one using what we call equilateral triangle. You remember what equilateral triangle is? Equilateral triangle is the type of triangle that the 3 sides are equal. So what is here is the same thing as here and the same thing as here. And if the 3 sides are equal, it then means that the 3 angles are equal. Are you getting it? And you know the sum of angle in a triangle is 180. So if these 3 angles must be equal, what do? We divide it by 3. And if you divide it by 3, you're going to have 60. So meaning that here is 60, here is 60, and here is 60 degrees. Are you getting it? Fine. And if we do that, let's assume the sides to be 2. We assume the length to be length of 2. Now, if I bisect this, bisection means to divide something into 2 equal parts. So if I bisect this triangle, I'm going to have here, because it's a bisection, I divided this one into 2 equal parts. So here will be what? 30 degrees. And here too will be 30 degrees. So let me bring it out and then use it to do what I want to do. So let me bring out one of it. This is 30. This is 60. Okay? Now remember this is equal to 2. This place is 2. If from here to here is 2 and I divide it into 2 equal parts, meaning that this place will be 1, right? So here will be 1. So here is 1. So we want to find here. We don't know this place, so let's quickly find this place using that Pythagoras theorem. Pythagoras theorem simply said that hypotenuse squared is equal to opposite squared plus adjacent squared. So if I'm now looking for opposite, it will be opposite squared is equal to hypotenuse squared, this close to that side, minus adjacent squared. Which means that opposite is equal to, you take the square root of hypotenuse squared minus adjacent squared. So let's use this thing here. So to get this, my x will now be equal to this one squared. Square root of 2 squared minus 1 squared. Are you getting it? Good. So this is square root of 2 squared is 4. Minus 1. 4 minus 1 gives me what? 3. So I have root of 3. So here is equal to square root of 3. So I've gotten the whole side. So can we now find our sine, cos, and tan? So we start. Sine 30. Okay, let me start with 60. When I'm done, then we'll do 30. Sine 60 degrees, cos 60 degrees, then tan 60 degrees. What is my sine 60? See, sine 60 means SOHCAHTOA. SOHCAHTOA. So opposite over hypotenuse. So opposite is SO3 over hypotenuse is 2. This one cos is ka, adjacent over hypotenuse. Adjacent over hypotenuse. Then toa, opposite over adjacent. Opposite over adjacent. Adjacent is 1, which is sentence. Is that clear? Good. We are finished with a sine, cos, tan of 60. So let's go to that of 30. So 30, we have the same sine 30, cos 30, and then tan 30. Are you getting it? So let's go to sine 30. Sine, we are now working with this particular angle. So sine, opposite over hypotenuse. Opposite over hypotenuse. Cos, adjacent. So this side here is adjacent to this angle. So adjacent over hypotenuse. So I have root 3 over 2. Which is this one. Tan 30 degrees. So tan 30 will now be opposite over adjacent. That is 1 over SO3. Are you getting it? Now remember what I taught you about rationalization of sod. We don't like having sod down. This is okay, but to rationalize it, you simply do multiply by what you have here, which is SO3 over SO3. This time this will give me SO3 or root 3. This time this will give you root 9, and square root of 9 is 3. So this is the same thing as SO3 over 3. Is that clear? So these are the special angles. Angle 45, angle 60, and angle 30. The trigonometric functions of these angles. Then there's another we'll look at, and that's the angles 90, 180. I will just simply show you the waves of sine and cos. It will not take time. Just watch the wave, how sine goes. So we look at this 1, -1. This is a graph. Okay, this is 0. So for sine wave, let's have 180, 270, 360, 450, and 540. We are moving in 90. Okay, so for sine wave goes like this. It gets to 1, then it comes down to 0, it goes down to -1, it goes up. So that's how sine. This is sine wave. Are you getting it? So meaning that sine 0, at 0, sine 0 is equal to 0. The function is 0. At 90, sine 90 is equal to 1, positive 1. At 180, sine 180 is equal to 0. At 270, sine 270 degrees is equal to -1, -1. At 360 is equal to 0. At 450 is equal to 1. At 540 is equal to 0. So all the multiples of 180, all of them will be equal to 0. So at every 180, the sine is equal to 0. So this is 90, positive 1. This one goes down to -1. 0 goes up to, so that is for the sine wave. For the cos wave, not cos wave. So this is for the sine. So for the cos moves like this. Because we need to know this so that when we start solving, we will not be surprised how we're getting the numbers we are using. Okay? So this is for cos. The one I did before was for sine, so this one is for cos now. So for cos, we have the same thing. We are still moving within 1 and 0. So cos moves like this. It starts from this, go up, like this. Meaning that cos 0 is equal to 1. Cos 90 degrees is equal to 0. Cos 180 is equal to minus 1. Cos 270 is equal to 0. Cos 360 degrees is equal to 1. So you will see something. You see that all the multiples of 90, they are giving you 0. But in sine, the multiples of 180, sine 180, sine 0, sine 180, sine 360, they are all 0. But in cos, sine 90, sine 270, sine 470, all the multiples of 90, they are 0. Is that understood? So these are the special functions we will have to know about trigonometry. Alright, so follow me in the next video where we will apply these ratios and functions that we have generated from this video. Okay, see you in the next video. Bye.